Yeah, thank you, Mike. So we are honored to have Dr. Henry Ruhl with us today. He's going to be telling us a little bit about the global observing needs in the deep ocean. Dr. Ruhl comes to us. He is the Central and Northern California Ocean Observing System called CENCOOS. There's multiple COOSs around the U.S. He's the director of CENCOOS, which oversees all aspects for that region, including governance, the observing systems, the data management, modeling, analysis, and education and outreach. He has expertise in several areas of oceanography, one of which is obviously the deep ocean, which we'll be talking about today. And with respect to that work, prior to being the CENCOOS director, he was the head of a deep seas group, which focused on deep sea ecology and themes of that sort. So right now, what he's an aspect that he'll be presenting on is a group called the Deep Ocean Observing Strategy, or GOOS. He is one of the task chairs associated with that and a co-author of one of the Ocean Obs 19 community white papers, which he'll be presenting today. So without further ado, I'll hand it over to you, Henry. Thank you so much again for agreeing to participate.
Thanks. Thanks for having me. And so, yeah, I'll be talking about global observing needs in the deep ocean, and it's really about the deep ocean observing strategy here, with some things tied onto it. So this is an effort of quite a lot of folks, really championed by Lisa Levin, but also Eric Lindstrom has been also very helpful along the way, as have many others. And so what is GOOS? And so the Deep Ocean Observing Strategy is a project of GOOS. It's looking to bring deep sea context to GOOS in many ways. And so add some coordination, networking around addressing science challenges that deep ocean presents. And really what we don't want to be doing is taking better advantage of activities that are happening, but also identifying gaps where they exist, whether they be in science questions, science themes, or in infrastructures or other things. And so question then arises, okay, what's deep? What does that mean? And so we've adopted a focus of below 2,000 meters for various reasons, but we also recognize that for many, the deep sea means below 200 meters or so, where the shelf break occurs, and also the deeper part of the photic zone sort of ends, according to most sort of conventional thinking. And so we have this sort of multi-use definition there. And I think folks in the line will be well aware that, of course, warming, ocean acidification, deoxygenation are major issues for the world ocean, as is changes in food supply and biogeochemical fluxes. We have these human pressures that are pervasive from fishing, oil and gas, potentially from seafloor mining, and of course, litter, which we hear more and more about every day. And just an example of the seafloor mining. So there's been more and more news about this. There's lots of exploration happening now. There are locations throughout the world's oceans where this might be occurring, and it includes seamounts and hydrothermal vent areas, as well as open abyssal plains. And the regions can be quite large, and so some of them are the claim areas can be the size of states or small countries. And although it's in an exploration phase now, it could be something that has impacts not only on the seafloor, but into the water column in major parts of the ocean. And so we want to be keeping an eye on this. And so our science goals really have three sort of main threads that I don't think will be foreign to you. So one being about ocean circulation and the transportation of heat, the heat flux of heat, and budgets around this. Another being ocean tracers and biogeochemistry, biogeochemical fluxes, both in the water column, but importantly also on the seafloor. And also understanding of deep sea biodiversity, ecosystem services, and the tensions of that against the human impacts that I was mentioning, and their relation to other ecosystem services that we have. There's also, I should mention, there's also this sort of more detailed list of science questions that we have, and there are derivatives that you can take from there as well. So there is some more thinking to that. We have our primary objectives. The first of these being we're working with the GOOS panels for essential ocean variables. So this is the Global Ocean Observing System, essential ocean variables. And so we're looking to evolve the specifications that exist using the GOOS framework to add deep ocean perspectives and context to these. They were largely and very understandably aligned with surface and coastal ocean thinking in mind. But for reasons I mentioned earlier, like seafloor mining, there's some good reasons to add dimensions to this, and so we're working with, and I'll talk more about that in a moment. And so another thread of thinking we have is to develop demonstration projects, and what this really means is working with things that might be happening already or are going to happen, and trying to tie together some of our strategic elements into these efforts. This includes bringing in new technology, using the fair data principles of findability, accessibility, interoperability, and reusability, and bringing in various existing assets. And so the sort of pillars of GOOS. And so to give an example of what that might look like, so in the Clarion-Clipperton fracture zone, so this is the big abyssal plain area and the hill area in the Northeast Pacific where seafloor mining might happen. We have, there's TPOS 2020 moorings activity, there are ghost ship lines, there are, of course, Argo floats floating around that area, there are models that are run that include that area, there's satellite oceanography products. So what we would like to see is those tools brought together to address the science challenges and baseline assessment, impact assessment challenges that are presented from the seafloor mining industry, as an example. And there's also the industry itself has exploration activities that include a wide array of scientists from different countries that are collecting data in a so far loosely coordinated way. I think it's fair to say, but the coordination is improving, and we want to try and help with that. And so we want to be serving as a communication hub to achieve that, and we also want to be reaching policy and influencing decision in some way, or helping that process, really. And so who are our stakeholders? So they run from industry, projects and programs, scientific and research infrastructures, government bodies, quasi-governmental bodies, and then also sort of UN and society-facing bodies. I think those will, many of them will be familiar to you. And here we have a chart that sort of illustrates the point that there's lots of deep ocean observing happening across several different sort of platforms and frameworks, but we want to be bringing this information together in a way that so far hasn't been achieved. And so GOOS began in 2011. There was some initial meetings and consultation documents developed. I sort of came into the GOOS frame in 2016 for a workshop, a fairly large workshop, and that developed a few documents, including a science implementation guide, which is now out. We've also developed a community white paper, which was referenced earlier for OceanObs, and we had a session at OceanObs, and now we're thinking in the future about working with the UN Decade and developing an implementation project for GOOS. And so the implementation guide is now available through a DOI at the Ocean Best Practices workshop, Ocean Best Practices website, rather, as well as our own GOOS website. We also have a poster on this, as well as an executive summary brochure, which we can share with you, however, printed copies or whatever you might like for your communities. We'd be happy to arrange that. And we have this white paper. It's receiving some nice attention, we think. And this importantly includes not just GOOS, but also folks from the ocean exploration community and folks that have been working closely with industries, in oil and gas industry, for example. And there's also another paper that's just about to come out that looks at ecological variables, ecosystem variables for deep ocean monitoring that includes, again, some GOOS membership, but also a broader community input. So we've been going to various people from the GOOS initiative have been going and attending meetings, for example, like POGO, the GOOS Steering Committee, the UN Decade for Ocean Science Planning meetings, the International Seabed Authority meetings in Jamaica, OceanObs, of course. And one of the topics that we've been, as I mentioned, that we've been working on quite a bit has been this essential ocean variables concept, adding, so we can see here, there's 3 panels for GOOS on this: physics, biogeochemistry, biology, and ecosystems. And the upper part of those is the GOOS existing EOVs or emerging, but also we've suggested at the bottom there a series of variables that mainly through the workshop we had in 2016, and we've been sort of working with the panels and other folks, other experts that include deep sea experts, to see how these might progress in the EOV framework. And I'll give you some examples of that. So we have ocean bottom pressure. So I think many will know that this can be very useful for a distributed network of ocean bottom pressure sensors, can be very useful for understanding ocean currents, waves, and therefore circulation and mixing and things, but also things like tsunamis and storm surges, which have a rather different geohazard early warning application. And so this physics EOV task team work has been led by Bruce Howe from the University of Hawaii. He's also working on a smart cable concept, which is sort of highlighted in the bottom right figure there, that could add ocean bottom pressure sensors in a distributed network and achieve a lot of what's described there. And so he's making some progress on having, and those teams are making progress in having some demonstration efforts to progress this. And they've also had a good relationship with the GOOS panel, and this variable is expected to join the GOOS EOVs. So another is ocean bottom boundary fluxes, and so this really is about seafloor heat flux, and this, of course, relates largely to hydrothermal venting and geothermal heating at the seafloor. So it's a poorly known aspect of the ocean heat budget, and so it's still under consideration, and the framing of the specifications of an EOV are still under discussion. The same is also true for ocean turbulence. I think widely appreciated that ocean turbulence is an important mixing term across a wide range of scales. And the Ocean Observations Panel for Climate is looking at this along with GOOS and seeing how it might be progressed, but it still needs a bit of thought as to how that might work. There's also a poster that summarizes this that I can share as helpful. I think some folks on the phone were part of creating this. And so this is in reference to the biological carbon pump, and this is one of the things that I've worked on in the past, and really the biogeochemical variables around it, particulate organic matter and dissolved organic matter, and things like seafloor fluxes and so on. They really sit in the intermediate space between physics and biology and ecosystems, and this is an area that Felix Janssen from the Alfred Wegener Institute is working with a group of people to help work on specifications for those items in purple. And on to biology now. So it wouldn't surprise you, I don't think, to hear that biology is complicated. So there's lots of dimensions to biology and biodiversity. But one of the messages that we want to be conveying, I think, and I think was coming through at OceanObs in Hawaii, was there's building blocks for this that exist, not for ocean observing, but also specifically for biology and biodiversity. where there are pillars of GOOS in organization, there are organizations that are looking at metadata standards for biology that are becoming more widely adopted. There's vocabularies that are agreed. There are international organizations working on communities of practice. There are organizations that are including biological observing into their ocean observatory efforts. There are organizations distributing this information and integrating it. So all the pieces are there, and we can be looking to try and figure out how to more efficiently put them together, I guess. So it's a bit of a web at the moment, and maybe a bit more of a streamlined thing is something we can achieve. It's also worth mentioning that biology and ecology sensing is maturing. So we have animal telemetry, passive acoustics, acoustics and optical backscatter, photography and microscopy underwater, genetics, artificial intelligence tools to digest what is some rather complicated information. There are examples of all of this that are happening in research, sort of the research operational oceanography, this sort of gray area in oceanographic observing programs, and so we can start to build on that. So the example that you see to the right, all that stuff is real and fairly well vetted as well. And so coming back to this list of biology and ecosystem EOVs, we have many of them that are, when we look across them, a lot of what we want to know in biology is already sort of covered there, but we do have some other things we're looking at to include seafloor sponges, so that there's importance for this in the vulnerable marine ecosystems that fisheries agencies look at. And I'll talk a little bit more about invertebrates, mainly benthic invertebrates here. So what might that look like? That's an emerging EOV at the moment. But one way this could go is that we could take advantage of model frameworks that exist already. So here we have on the top right is a IPCC affiliated biogeochemical model, that one of the outputs of which is this food supply to the seafloor, this POC flux, that then drives a size class model for benthic biomass. And we can then apply scenarios, these climate scenarios, to these models, and this has been done. And on the top left, you see 1990 to 2100 seafloor biomass across a range of size classes, and divided on the figure into depth. And we can see that the deeper depths are potentially facing rather large percent changes, and so 40% or so changes in biomass. And the changes are really pronounced in the Northeast Atlantic. And so this is not a small change. We're talking about sort of fundamental changes to the biomass of the world. And so not only are there model tools that we can use to better take field data and parameterize those models more effectively for more parts of the world, but we can then also collect field data in more efficient ways now. So this is a photographic survey that was collected in September of this year. On the right, you can see the full extent, and that's about 40 hectares. So that's a pretty huge area, like 40 football fields or so. And you can see in all of that area, you can see animals that you would see if you were standing on the seafloor. And so you can then do size-specific biomass, and also see things like litter, corals that are important for management, and also sort of cool things like this whale skeleton. And this is a project that was being led by the University of Southampton with Blair Thornton and some colleagues at the National Oceanography Center. And so recommendations from OceanObs 19. So we have 3 sort of core recommendations from our session. The first of which is to extend the ocean observing capacities to a global scale, really, and take advantage of the UN Decade Framework, take advantage of the EOV framework, and build on existing assets and networks. And so we're looking to better link with BGC Argo, Deep Argo, GoShip, and Ocean Sites. And I was pleased to see just recently that GoShip is having adopting some, or thinking about adopting some biological observing efforts through a SCORE group, improving standardization of observing data and products, but building communities of practice where we can have these pipelines of going from data to curating it, adding value, and developing products that people care about. And so these communities eventually need to connect with policy and so on. And so, yeah, so in the end, I think a lot of people know that this is about building partnerships and relationships to make these things happen. And these partnerships can include industry as well. And so, for example, the oil and gas industry can figure out a way to perhaps more effectively engage with GOOS than it has so far. We have, of course, the Ocean OBS 19 conference statement, which now includes coast to deep ocean, better use of models, and other things that relate to our efforts. And we also have just submitted to IOC a documentation that summarizes a lot of what I've already mentioned. And so we're looking to continue down that track. This also includes mention of CLIBAR, and so we're looking to work with the Ocean Model Development Panel and the Global Synthesis and Observations Panel on CLIBAR. And we're also looking to, as I mentioned, have an implementation project that takes a lot of what I've already mentioned and looks at trying to action a lot of it. And what that means in a lot of ways, so we have this nearly finished here. We have this these gray sort of boxes in the sort of ecosystem of going from scientific need to good outcomes for society. We've been focusing on these gray boxes, and really what we want to be doing is the whole package, and this implementation project will hopefully deliver some of that. What can you do? So we have an inventory on the GOOS website that you can add your observing system du jour if it's not there. We have also a town hall in San Diego at Ocean Sciences that's coming up. Please communicate with any of us in the GOOS sort of leadership. I'll give you some contacts there. And groups are encouraged where they find that they might be aligning with GOOS to express to us that that is the case, and we can help highlight your work, help bring it in, make sure that it's aligning with GOOS in the most effective way possible. And that includes a lot of the principles I've been talking about already. And the key contacts are here. So we have a coordination with and a co-chairs. There's a new co-chair with Felix, and task team leads around each of the EOV panels, and data and cyber infrastructure task team. So with that, I'll take questions.
Yeah, thank you, Henry. I do want to let you know that we can help promote your town hall for I think you said Ocean OBS, the Ocean OBS 2020 meeting. So yeah, we'll help promote that within the community as well. So now it's time for questions. We're at 26 after the hour. We can go for 10 minutes if those of you who are online can stay. If you have to leave at 12:30, we understand. So the floor is open for questions.
Hello, Henry. This is Chanelipo.
Hello.
Hi, I have a question about the...
Hello, Shane. I think you're on mute again.
All right, trying again. My phone was very bad. Can you hear me?
Yes.
So, Henry, you showed results from a IPCC-related model that showed change of biomass at the seafloor. Would you be able to? And I was struck by some of the positive changes that are predicted by this model. Do you know what they correspond to?
So that I think that's Arctic really is what. So shallow water and polar changes is where you see this, and the declines are really heavily impacted by the Northeast Atlantic changes in the thermocline structure.
So
in this particular model framework.
So the diagram on the right, is it at the bottom or is it like vertically integrated?
No, so that's total biomass for the seafloor, yeah. So there has been previously work that showed this for the water column. I believe, I don't remember if it was the upper 100 meters or something more integrated, but it of course is not surprising to see that that sort of pattern would be mirrored at the seafloor. But one of the advantages that we can get by doing this kind of work is we can see across many different size classes. So from small worms and so on to large animals that like echinoderms and so on, which each have different ecosystem functions at the seabed and might be impacted by industry activity differently.
Okay, I was just curious about the positive changes that are predicted, like at mid-latitude in the South Pacific and South Atlantic. I was just curious as to what that corresponds to.
Yeah, okay, those, yeah, I guess if you do done modeling like this, it's important to recognize some, going to be careful about too much attribution for specific locations, but Andrew Ruhl can help follow up with that if you know him, or I can put you in touch with him.
Okay, thank you.
This is Yolande Sarah. Can I ask a question? Can you guys hear me?
Yes, we can hear you fine.
Hi, thanks for a great presentation. I wondered about, I'm on the East Pacific Task Team for TPOS, and in listening to your talk, there's some overlap as far as some of the coordination challenges that the deep ocean faces that we're also facing with the East Pacific Task Team. And I'm wondering, you mentioned industry, and it sounded like you are, that you guys are all working together, at least some industry partners. And I'm wondering, what's the vision going forward? Are you finding that they're collecting their own data and sharing it with you? Is that the vision? And is that kind of, for the most part, an accepted vision by both parties? Or how does that private data get blended into this data repository idea that that you're hoping for?
Yeah, that's a great question. So there's two main buckets to that. One is the oil and gas industry, and the other is the seafloor mining industry, and they're very different. So the oil and gas industry has been collecting data, of course, in many ways for many years. There are examples in almost all of the oil and gas companies of some deep sea project that has brought data into the science community, but it's there's not really a vision yet or an agreed sort of value proposition across these sectors to do that in a more comprehensive way. A lot of the sort of pilot projects have not really been scaled up in the way that we had hoped, and so that there's some work that we think the industry can do on their own, perhaps, to agree amongst themselves the value proposition for aligning with GOOS more effectively. I think we can suggest things, but it's really for them to agree this, I think. And so seafloor mining sector is a little bit different in that the UN has this body called the International Seabed Authority, which has a remit for the area, so the area beyond national jurisdiction, otherwise known as the area. And so this covers, of course, much of the world ocean, and the seafloor is their area where their governance applies. And they have, if you're doing seafloor mining exploration or exploitation, you need to be submitting data on baseline assessment and impact over time as a contractor working in a particular area. But the planning for this is still very early. So far, the sort of data integration and standardization and so on is pretty far from where we would like it to be in the GOOS community, at least. But there's a lot of there's time to work some of this out, and there's a lot of potential, as I say, because I think that a lot of the pieces are there. But there's some real need in that community to adopt this, and it's up to the ISA in some ways to come along for this as well, because they have a UN responsibility in this area.
Okay, interesting. Thank you.
So Henry, this is Mike Patterson. I have a question regarding the EOVs. If you can go to your list of EOVs. So CLIVAR has a particular focus on the role of the ocean in climate variability, and of key importance is the ocean circulation, particularly at depth. With interest in understanding transports, both in the horizontal and vertical, so upwelling, overflows at the bottom, and water mass transformation as well. So where does that end up in the list of the physical EOVs? Is it all subsumed into subsurface currents, or is there the need to bring forward some of these transport issues at depth that are going to be so critical to the movement of heat within the system?
Yeah, and great question. A similar thing applies to the other. Similar things apply to the other subject areas as well. So I think the EOVs are best framed when lots of different things can be derived from them. And so I think a lot of what you're thinking about there could be derived from measurements of currents in the surface and subsurface. And when one goes into the subsurface document, that it should be clear if it's talking about some depth horizon limited thing, like is it actually going to the seafloor or not? And that sort of brings us to another issue with respect to currents and how they're represented. So the community makes current measurements in particular places, and then often puts those into estimates of flow. There's also other kinds of measurements that help that, of course, but our ocean models were designed largely to be surface facing, and so the seafloor also has all kinds of influences on the circulation, and the closer you get to the seafloor, the model boxes become larger and less effective at actually representing currents at the seabed. And so there's potentially, if there's sufficient interest from the mining industry and others to understand the role of the seafloor and ocean mixing, this could be a sort of another evolution in ocean modeling where we more effectively consider the boundary shape at the seabed.
Right. Thanks.
In the case of biology, diversity is really a derived metric across lots of different classes. It's mentioned specifically in some of them and not in others, but there's also rate things and other things that can be derived in some way, in some cases.
So if I can just follow up from Mike's question, this is Shanalipo. One of the reasons why ocean bottom pressure is being put forward as a EOV is one of the reasons is that looking at differences of pressure, one obtains horizontal transport. And so that would answer one of the questions that you had, Mike, regarding transport, mass transport, basically. But one of the issues that we have is that presently the technology of ocean bottom pressure measurements do not allow to get long-term trends, because bottom pressure recorders basically have a drift in their record. So you can look at relatively high frequency transport from bottom pressure, but not so much for long-term, which is a technology challenge, actually.
Thanks. I have another quick question, Henry. On your list of technologies, we saw the usual suspects with regard to the physics of the deep Argo, the ocean sites, as well as, what was the third one?
GOOS ship, maybe.
GOOS ship, yeah, the repeat hydrography. And is there a place here as well for the deep sea cables? And we had earlier this year a presentation on a new large initiative on the deployment or use of deep sea cables that are used for the telephone or telecommunications industry.
Yes, yeah. So that's sort of that's where the ocean bottom pressure sensing will hopefully expand. And I believe what you're referring to is the Smart Cable initiative from Gurus Howe. Yep,
that's right.
And so that's what's depicted in this bottom right panel here. And so that he is making headway and getting a demonstration for this. Excuse me. You know, that network can provide sort of a huge step change in the availability of data that has some caveats, as Shane mentioned, but also has lots of really sort of comprehensive data prospects.
Right. Great. Any other questions for Henry?
We are thinking of that for our GOOS framework. Yeah.
Well, why don't we go ahead and stop here then? We're almost 40 after the hour. I want to thank you, Henry, again for presenting and answering the questions. We appreciate your time, the time you took to prepare and give the talk. All your slides will be shared with the members of the PAWS panel, and if anyone else outside of PAWS is on this call, send me an email and I can send you a copy of them. A recording of the webinar today will be available early next week on the US CLIVAR YouTube channel, so please share it with others that might be interested in the GOOS topic who weren't able to be here in person online today. And then our next PAWS panel webinar will be a month from now, Thursday, December 5th at noon. The presenter will be Brady Ferster of the French Institute Pierre-Simon Laplace, the Laboratory for Oceanography and Climatology in France. His talk is entitled The Role of Teleconnections in Southern Ocean SST Variability. So please join us for that if you can. And I want to thank everyone for joining today. Bye-bye.
Thank you.
Thank you.